AccuOpt presents.
My name is Baburaj. I am representing a company called AccuOpt. AccuOpt is the infrared division of Tempsense Group. So today we will discuss about thermography and its industrial usage. So I prepared this, not too many technical part, but more towards this application part. And about me, since last 24 years, I am working in the field of non-contact temperature measurement in form of pyrometers and thermal images. We are the only company in the country manufacturing infrared pyrometers and also industrial radiometric thermal images. So before starting this topic, I will just brief what we are and what we do and what kind of products we are offering to the market. I don't take much time, it's only 1976. So under Pyrometer Group, we have different division like panel division, electronics, and temperature division. So I am from the temperature division. The temperature division is called Tempsense Instruments. And in temperature, we have a marathon for heating and accurate sensing technologies for infrared pyrometers, accurate optoelectronics for thermal images. Then we have production facilities in Germany and in Indonesia. So Pyrotech Group, we are into panels and control desk, Tempsense thermal and cable solution, PEPL lighting and electronic solutions. So I represent the company called Tempsense. So these are our major products: thermocouples, RTDs, thermowells, temperature gauges. Then we have infrared non-contact pyrometers, thermal imagers. Then we have temperature calibrators. We also manufacture furnace monitoring cameras. Then we are also manufacturing this basic raw material for a thermocouple, that is thermocouple mineral insulated cables and nickel conductor. And we also give solution for fiber temperature sensors. Then we have wireless temperature transmitters, data loggers. So we are working in the field of thermal and cable industry. So our vision is to lead the thermal and cable industry with passion, innovation, excellence, and reliability. So this is our vision. So we have, for this temperature sensing, we have 600 employees, direct employees, and altogether we have 1,200 people here. We are doing business in 75 countries. Last year turnover was 41 million US dollar. We have 6,500 customers and 9 patents, and we have 40 years experience in this temperature field. So these are some of our production facilities here in India and as well as in Germany and Indonesia. So this is what we do. So now we can come to this main topic: thermal images for industrial application. So thermal images has vast applications, not only for industry. It can be used for surveillance, it can be used for medical application, it can be used for defense application. So today we will discuss more towards this industrial application. So there is a saying in worldwide that seeing is believing all the world over. One eyewitness way more than 10 hearsays. So if we see something which can give a more detailed, elaborated information rather than we get some explanation from our subordinates. Suppose if you are an electrical engineer and your subordinates come and say that such and such motor is not performing well, I feel some problem is there. So you cannot identify what exactly he is explaining to you. But if you see a thermal image of that machine, then precisely you can see what exactly is happening with that equipment. So that's what saying the prevention is always better than cure. Because unexpected shutdowns is very expensive for any industry. It not only affect the process and it is very expensive, it also directly concerned with the safety of your employees, valued employees. So this thermal imaging tool is basically used for predictive and preventive maintenance as well as for process monitoring. So if you are deploying such equipments in your process, so you can predict the unwanted shutdowns. So it will save a lot of money and time. You know that reducing energy use make perfect business sense. Energy saved is energy generated. It saves money and helps corporate reputation, helps everyone in the fight against climatic change. Because whenever we are burning fuel, it is affecting our atmosphere. So like a human body, you know, overheating is a frequent symptom of equipment that is fault or in poor condition. Like a human body, if the temperature is increasing, it gives a symptom that something is going to happen with your body, like your equipments, your process. If it is exceeding a certain temperature level, that gives an indication to you that in near future, something is going worse with that process or that instrument. So this type of tools will help you to find early the fault and the problems. Minimizing heat loss and wastage will save energy and reduce operating cost and carbon emission. Thermal imaging can be used for process monitoring and control, effective preventive maintenance, improve reliability and safety. So very simple word, we can explain how this technology works. Thermal imaging, how it works. We know what light is. When we say light, it's an electromagnetic radiation within a certain portion of the electromagnetic spectrum. Electromagnetic spectrum is such a wide band of energy. It starts from gamma rays and goes up to radios and other. So when we say light, normally we take in account of visible light, which is seeing by human eye. But that is not the case always. You know, for example, if we see this apple as a red apple, for us it's a red, yes, okay, good. But for your puppy concerned, it's not a red apple. For him, it is either a brown or it's a gray apple. Although we are seeing the same object, because the dogs, they are color blind with especially red, and they can see in the spectrum of yellow and green. So whenever we see light, don't always think it's a visible light. There are many other lights present in electromagnetic spectrum. So you know that these insects like bees and all, they see in infrared, ultraviolet rays, and human, they see in visible spectrum, and the reptiles like snakes and all, they see in the infrared. So there are a different type of energy like gamma rays, X-rays, ultraviolet, visible, infrared, microwave, and radio. So these pyrometers and thermal images, these are working in either near infrared or up to mid wavelength infrared, up to 8 to 14 micron wavelength. These sensors are working. So in the universe, everything absolute zero is emitting radiation, irrespective whether it's a sun or it's a cold iceberg, whatever. It is always emitting radiation. Emission of infrared radiation increases as the object's temperature gets higher. So as the temperature of the object is increasing, the intensity of emission will increase. So that's why if you are standing near to an ice box, you will not feel cool. But when you are standing near to a firebox, the fireball, you will feel hot, because the fireball is emitting more heat than this ice box. So infrared sensors is like our skin. It can detect this emitted energy, and by using appropriate electronics, you can convert this incident energy into voltage, and you can process it, and you can make picture, you can make voltage or current output. So this is the basic structure of a thermal imager. This construction of thermal imager is just like a CCTV camera. It has all the components which is inside a CCTV camera. First of all, it has a lens to collect the energy from this object. So according to the application, we can select different type of field of view, different type of lenses. Then the sensors which you are selected is working in a special wavelength. So what you do, just after this lens, we put a filter which is filtering the unwanted energy, and only transmit the energy with this, which is suitable for this sensor which you are using. Then the sensor is giving you some faint output, which is amplified, and by using processor or controller, you are processing it, and it can give you a video output or a inbuilt display output like that. These sensors are called FPA sensors, focal plane area sensors. So according to application, there are different type of resolutions available, like 80 by 80 pixels, 160 by 120 pixel, 384 by 288 pixel, 640 by 480, then 1280, like that. It is less like when you are going to buy a phone, mobile phone, you say how many megapixel cameras are there, like this. According to your application, according to your budget, you can select different type of sensors. So a key commercial benefit of the technology is that the potential fault can be identified quickly and without shutting down or isolating plant and process. So the beauty of this technology is you don't need to shut down your process to check that instrument. So when it is working, you can go to that place and you can see how precisely it is working. And user can be located at a safe distance from this potentially hazardous equipment. Suppose if you have an acid tank, you want to see whether these insulations are good or not. So from a distance of 25 meter, 50 meter, you can take the thermal image of that tank and you can see if there is any hotspot. And there is no scaffolding, ladders are not required. You can find a suitable place in a safe distance. You can measure without any physical contact. It gives a very high safety standards to valued employees. You can see here, this picture is a thermal picture. It has nothing else. It's only a simple thermal picture. On the right hand side, you can see a graph, different color graph, pellet, we call it pellet. So according to the temperature, the color will change. So you can see that the black color represents minus 10 degrees centigrade, and the temperature increases. You can say the red color, it is somewhere around 30 degree. Blue color is somewhere around 2 degree, 3 degrees Celsius. So this is the pellet which gives an indication of temperature. Now you look into the picture, it says a lot of story. First of all, it's a dog, maybe a wolf. And we can say that it is not a dead animal. It was not sleeping for a long time. How we can say that? You see the leg of this dog, you see its hair, its nose. It is comparatively hotter than his other part of body. That means he was working for quite long time. That's why his muscles are hot and his nose is hot. His ear is also hot. So it gives first information that he was walking since a long time. It also gives you an indication that it is not in a hot area because his body is so cool. It's somewhere around 2 degrees. So that means it is somewhere in icy area. You can also see he got wounded. He got a serious wound in his leg. So this much of information a single thermal picture can give to you. Now suppose you imagine, instead of this wolf, if this is a thermal picture of your motor, the same type of information, without going to this site, by sitting in your room itself, you can understand, yes, there is a problem with my particular asset. So this is the beauty of this technology. Having a thermal image is nothing. Making a good analysis by seeing this picture, that gives you the right information about the process and the temperature increase reset. So you can see some applications here. In the right side, there is a ladle which is used to transport a molten steel from one place to another place. So if the outside is steel and inside there is a refractory lining, so from outside you don't see anything other than this steel cap. So if inside this refractory is weak, this hot metal will come out one day if you don't have the proper information. So by seeing the thermal image in the left side, you can see both. Either there is a hot spot or there will be a cold spot. Cold spot is generating because this slag may be deposited on this brick. So that area will be a cold spot. And if there is a weakness in the refractory, it will show as a red spot. Down there, you can see the one connection is overloaded. The motor, you can see is some part is getting overheated. So a few area of application we can discuss. As I told you in the first instance, energy saved is energy generated. According to US Department of Energy, more than 45% of the fuel burned by US is consumed to raise steam. But steam is not free. It costs approximately 18 billion annually to feed the boilers generating the steam. So if you are transporting your costly steam from one place to another place by using pipeline, and if you don't know whether this insulation is proper or not, you are unnecessarily wasting this energy. So if you have proper mechanism to see the thermal image of these pipings, so you can see if there is any insulation leakage, you can use it vice versa as well. You can use this thermal imaging to see the cold spot as well in the pipelines. If you are transporting some oil or cool air or any other gases, you can have thermal imaging and you can find out the leakage in the furnace. So for the pipelines. Here you can see there's a motor and its drive. Electric motors consume around 60% of electricity delivered to the industry. So some of the power delivered by an electric motor is consumed by components, drive system. So here if you have a proper monitoring of your critical assets, critical motors, you can predict the ongoing process and any possible damage of the shaft or any other part of this valued motors. Here you see this is a tracing electrical fault. Here you can see that one phase is overheated. So this thermal imaging can give you an indication. Yes, this particular one is hotter than the other part. Now you have to analyze why it is happening. It may be due to underrating or overloading of the equipment. It may be imbalance loading, loose connection, then insulation damage, incorrect voltage. Suppose if there is blocked ventilation. So the reasoning is our responsibility. This equipment can give you an indication that this part is hotter than the other part. Then we need to put our brain why it is happening. So then you will get the real answer. This I have already explained that not only for ladles. So this system can be used to see the refractory healthiness in furnaces. Wherever you have refractories and from outside you don't see the change unless it is happened, the damage is happened. So periodic thermal imaging of your furnace wall will give you an information whether any part is getting deteriorated. And this is also used in chemical and petrochemical industries to continuously monitoring the flare state. All these unwanted gases, which is going through this flare state, need to be burned properly. Otherwise, these toxic gases will go into the atmosphere and it will be either explosive or dangerous to the human life. So you need to monitor this flare state continuously. Also the pilot flame. Because if this main flame turn off, then this pilot flame will help to reignite it. So you need to have a continuous watch over this main flame and this pilot flame. So what happens in daytime with naked eye or a normal CCTV camera, you cannot find out such type of flames, especially in a sunny day. Because most of this flame, when it is in a sunny day, is more clear flame. So by naked eye, you cannot see this. And you need to do it in every condition of climate, day and night. So you can put a thermal camera. It can measure from 400 or 500 meter distance. And you can put a, I have drawn a square or a triangle here. And if there is no flame inside this, if there is no temperature inside this box, you will get an alarm. There is no need that the operator should watch this flame continuously 24 hours. So this system will work 365 days in all conditions. irrespective whether it's sunny day, rainy day, whatever. So this is a very good application for flyer stake monitoring. And this is also another application to find the earlier fire detection in the cold storage, because the coal piles, when it is in an open or in a closed area, due to this high humidity and all, there is always a chance to get fired. So what you can do is you can deploy 2 or 3 online cameras according depending on your size of your coal yard. Normally what we do, we install the system on a pole. There is a PTZ, pan and tilt zoom system. Inside that box there is a visible camera as well as a thermal camera. It can rotate 360 degree, and wherever there is a hotspot, it can take the picture, and it can send you an alarm that a particular area is getting overheated. So this will give you very good advantage to prevent fire in your coal yard. Here you can see this is a glass melting furnace. So glass melting furnace, we can deploy a thermal camera with a suitable water cooling and air purge unit. So it can give you the temperature of the melt pool. It can also give you the refractory, and it can also give you the quality of the burning of your fuel and the direction of the flame, whether it is focused to this melt pool or it is focusing towards the refractory wall so that it damages the wall. So we have very special mechanical and cooling arrangement to deploy such thermal cameras in a glass melting furnace. By deploying such a camera, you can save at least 30% of your fuel by precisely measuring the temperature inside the burning furnace. And this is the example of a cement kiln. So cement kiln, you can either use a normal camera or you can use a thermal camera with proper cooling and retraction system. So if you are using a thermal camera to see your burning area, it gives the temperature of the flame. It can give the temperature of the clinker forming inside. It also can give the temperature of your refractory wall. So by seeing all this information, the operator sitting in the control room, he can take a decision how much fuel he needs to inject so that the clinker is formed properly and also he achieve required temperature. So this is a very good tool to take a decision about the consumption of energy. If you are using a normal camera, you can just see the process. It don't give you an idea of the temperature of clinker or flame. So you are burning your fuel randomly. This is also very good equipment to deploy on the street to see whether any of the passing by trucks is overheated axles or the brake pad is hot, and it's very fast. So when your vehicle is moving 80 or 90 miles per hour, it can take the thermal picture of its brake and its axles. Then you can take preventive action by stopping that truck nearby, and they can take preventive action for that. And this is also a very good example for monitoring electrical switchyard. So conventionally what we do in almost every industry, we can see that a person is going to switchyard. Normally it is not allowed to enter in a very high voltage switchyard. So normally what he is doing is he is going there with a portable thermal imaging, and he is taking the thermal image of different area of interest, and he is noted down in his diary and going back, and I don't know what is happening to that data. So that is the conventional method. It is not accurate. Also, it is not good to use a portable thermal camera, especially in the monsoon season, in the rainy season, in the switchyard. So what we do is, as I explained in the coal yard application, here also we can deploy on a pole, especially the pole, it is looking to all this equipment. and it is in a PTZ. It can rotate in 360 degree, and there is no need that the entire switchyard you need to scan. You have special instrument you need to be monitored. So you can plan it, you can program it in this software. This instrument I want to monitor at this time interval. So all this custom modified software. So you can plan it, you can program it. Accordingly, the system will rotate. You will stop you will take the picture. And if there is any abnormality, it will send you an email with the location and the visible picture as well as the thermal picture. So this will give you a very good advantage to stop unwanted breakdowns in your switchyard, because a switchyard failure affect your total process. So this is very, very economic solution, and it gives you a headache-free operation in the electrical switchyard. It can also be used for quality control for these solar panels, then glass bottle manufacturing, packing industries, and many other applications. Here you can see it is also used for die temperature monitoring in pressure die casting. If you don't know the thermal profiling of the die, it will directly affect your process optimization. It also give very good quality control. Then it can give you dimensional accuracies. If suppose if some part of the die is cooled than other part, then obviously you say that this product will not come out, and there are many. Then you need to do by trial and error. Many parts will go wrong, and after 6 or 7 trials, you will have a one good unit. So it gives you energy efficiency, die life, and less maintenance, then process optimization, quality control, dimensional accuracies. So this is a very good tool for this die temperature monitoring. Here you can see that it is not only used for this temperature measuring application, it is also used for the surveillance application. So in night vision cameras, it can give you crystal clear picture even if there is no light. Here you can see nowadays in many European countries, deploying CCTV cameras are not desirable because of this privacy. People don't want to take their visual picture because of many their private reasons. They don't like to observe by a normal CCTV camera. So in that case, what you can do is you can deploy thermal imaging cameras, because you don't need to see his face or any part. So you want to watch his movement. You want to see whether he is entering to any unauthorized area. So like in airports and all, any other security related area, you don't need to see the face of the person. You need to see whether any person is intruding to that area. So to have the privacy on road, you can use thermal imaging cameras for such application. And these are the different type of thermal camera portfolio which are available from us. It can start from 80 by 80 pixels. If you know, different application need different type of resolution. There is no need that every time you need to go for very high resolution cameras and very high resolution lenses. Suppose if you are looking to your moto, you can use 160 by 120 pixel, which is very economic. Even this 80 by 80 pixel camera, if someone of you from the cement plant or steel plant, I will give you a small example that conventionally what we do, when this cement clinker, when it is coming from the cooler to this conveyor belt, normally we deploy a pyrometer to measure the temperature, and according to the temperature, we start the sprinkler. So what exactly is happening? This pyrometer is measuring a small area. That is the main difference between a pyrometer and a thermal imager. Both are working in the same technology, but in a thermal imager, we have number of sensors, but in a pyrometer, we have only one sensor. So if you are monitoring a conveyor by using a pyrometer, you are measuring only a small spot. But at the same time, if you deploy a 80 by 80 pixel camera, you are covering the entire conveyor, and you can save conveyor more efficiently. So 80 by 80 pixel thermal camera is equally priced than a pyrometer. earlier, say around 5 years back, these thermal images were very expensive. It was not so affordable for a normal company. Nowadays, this is made in India, 100% made in India. All these components is homely developed. So we just start from this chip level itself. Chip we are importing from France. The rest of the things we do here. So it is very economic, and we have a team of 80 specialized people to help you to select good cameras, to select different type of applications related software. So it's a very good team. So whenever there is a requirement, you can just write to us, then we will recommend you what kind of cameras you need to use. So we have 80 by 80. It can start from -20 and it can go up to 1700 degree temperature. So this thermal camera, the beauty of this 80 by 80, 160 by 120 cameras, it can be a replacement of pyrometer. There is no need of computer to operate this camera. This camera is directly giving you analog output. That means if you install this camera and if you draw a region of interest, and according to that region of interest, it can generate 420 milliampere. And 384 by 288 and 640 by 480, it needs a computer because this data is too high. So computer need to be there to process this data. So we have 80 by 80, 160 by 120, 384 by 288, 640 by 480, and we have another camera that can go up to 1800 degree. That is especially for very high temperature. It can go up to 3000 degree. First 4 cameras, it can go up to 1700 degree, and the last one can go up to 3000 degree. So this is the brief explanation what I had. So actually this solution is infinite. It can be used for many other applications because during the time of COVID, we have sent a lot of cameras for human body detection. It can be used for veterinary application because if you have a very big poultry farm or pig farm, it can be deployed. It can be deployed in the horse treatment. So there are applications. Thank you for attending this webinar. So if you have any questions, you can send me email. I will try to explain you. And regarding RDCS and JSPL and VSUVS, we will contact you separately and we will submit you the offer and details, whatever we committed. Thank you all. Thank you once again.